Okay, let's continue our discussion still on moment of a force about a point or a certain axis. Okay, dapat ma-master natin yung pag-solve ng moment because we will use this later on in solving for resultants of uh, force systems. No? Okay, so let's try to solve this problem. A 90 Newton force is applied to the control rod AB, shown. Knowing that the length of the rod is 225 millimeters, determine the moment of the force about point B. So we have this force, 90 Newton force. Meron siyang angle of inclination there. That's 25 degrees. Is it 25? Yeah. 25 degrees. Inclined din yung ating rod at 65 degrees from the horizontal. Okay, we solve for the moment of that force at point B, about point B. Okay, we're going to apply again the Varinon's theorem, okay, to solve this problem. Now, there's a different, I think merong ibang different method na present dun sa module natin sa solution, but iba na lang i-present ko dito sa video natin. Okay? And so, first, we need to solve for the components of the force. No, mas madali kasi yun. Apply natin yung Varinon's theorem or the principle of moments. Solve nga natin yung components ng force natin along x and y axis. Okay. Okay, so what is Fx? What is Fy? Fx, so we have 90 cosine of 25. Fy is 90 sine of 25 degrees. Directed siya downwards yung Fy natin. Okay. So, ilan yun? Hi, ma'am. Alright, Fx is... konting interruption lang. Fx is 81. Is it 81? I think so. So, 81.568 newtons. Fy is... wait lang. Compute natin. Sine. It's 38.036 newtons. Okay, next. So alam na natin. So yung moment ng 90 Newton force about B is also equal to the moments of Fx and Fy. Okay, add lang natin yung moment ng Fx and Fy. That will be the moment of this force relative or about point B. Okay. So next is i-compute natin yung perpendicular distance or the moment arm of each force about point B. Again, ang diskarte natin para para ma-identify natin yung moment arm. So for Fx, mag-drawing lang tayo. Extend lang natin yung line of action ng Fx horizontally. Okay. Yung iba kasi nahirapan yata sa pag-identify ng moment arm. Pero kapag nakapag-practice naman tayo sa pag-solve ng moment ay later on madali na lang ma-identify yung moment arm. So yung Fx, moment arm ng Fx natin, we draw horizontal lines sa line of action ng Fx, horizontal lines sa my point B where we are summating our moment at, and then you draw a vertical line kahit saan naman, no? Vertical line between these two lines. Kakaroon ng problema sa video. Vertical line perpendicular. So yan yung distance na Yan yung perpendicular distance, which is the moment arm of Fx about B. Okay. Okay. Next naman, next is yung moment arm ng Fy. Ano naman yung moment arm ng Fy natin? So, moment arm ng Fy, so from yung line of action ng Fy, drawing lang tayo vertical line. Okay. Ganoon din sa point B, drawing tayo ng vertical line. Okay, and then drawing tayo ng horizontal line perpendicular. Perpendicular sa dalawang vertical lines. Yan na yung moment arm ng Fy about B. Okay? So, mapapansin ninyo, kung mapapansin natin, itong distance na to ay equal yan dito. So, distance. So, bubuo tayo ng triangle. Ayan. At yung distance naman na yan ay equal din yan dito sa distance na yan. Okay? Okay. So, ito yung moment arm ng Fx natin. Ito yung moment arm ng Fy. Okay? So, I think we're good. Now, let's solve for the moment of the force about B. So, moment ng force natin about B is equal to, so, Fx, yung Fx muna. Fx would tend to rotate, the bar, ano ba itong, rod, clockwise, in a clockwise manner or direction. So, and then yung point natin, i-rotate niya clockwise. So, that's positive, no? So, 81.568 newtons times yung moment arm niya. Anong moment arm ng Fx? Ito. Yung distance na yan. Yan. Moment arm. So, given yung length ng bar, given yung angle of inclination, that means we can solve for this distance. So, what is that distance? So, ano yung distance na yan? This is, itong distance nito, that is, hypotenuse times, kasi given yung angle natin ito eh. Ito yung distance. So, right triangle, opposite over hypotenuse. So, sine function. So, opposite over hypotenuse tayo. So, sine of the angle 60 degrees is equal to opposite, yung hinahanap natin na distance, over hypotenuse. Which means that this distance is actually the product of the hypotenuse, which is 2 to 5 mm. I-convert na lang natin sa meters. So, that is 0.225 meters. Okay. Sine of 65 degrees. So, yan yung distance na yan. So, yung moment arm natin, 0.225 sine of 65 degrees. Okay? Ayan. Next, Fy. Yung moment naman ng Fy natin. Moment ng Fy. So, we have Fy tends to rotate ito, yung bar or yung rod para pag hihilain niya pababa yan, magro-rotate yan ng counterclockwise. So, minus siya. So, minus, we have 38.036 newtons times yung moment arm niya. Yung moment arm niya, perpendicular distance nitong dalawang parallel lines na yan. Ito. Okay. So, adjacent side yan. So, it means cosine. Okay, cosine. So, that is 0.225 cosine of 65 degrees yan. So, moment arm, 225 cosine of 65 degrees. So, yan yung moment ng force about point B. And that is equal to is 13.016 Newton meter. So, yan yung moment niya. So, positive, ibig sabihin, clockwise yung direction ng moment. Okay? So that's it. That is the moment at point B. Okay, next. And perhaps the last. Last na ba to? Last example natin for moment of a force about a point. Okay? So determine the total moment of all forces about point A. So maraming forces. That's a lot of forces. Okay? So, ayan. Yung mga inclined forces, i-convert na lang natin yan sa components niya. Okay? Itong 160 newtons, i-convert na lang natin sa components. Okay. Lagyan na lang natin ng label bawat force. Let's say this is F1, F2 ito, and this is F3. So this is F3x and this is F3y, and this is F4. So this is F4x, F4y. Alright, okay. Okay, next is to solve, syempre yung total moment about point A would be the summation of moments of each force about point A. So let's start with F1. So moment at A is equal to, so F1, so horizontal siya, hindi siya inclined. Horizontal yung line of action ng F1 natin. F1 is 180 newtons. It is point A. It would now tend to rotate. I-rotate niya yan in a counterclockwise manner. So counterclockwise. Ganon. Sound effects. That's 180. So that's negative 180. So again, ang sign convention natin, clockwise positive, counterclockwise negative. Yan. But you can use different sign convention, just be consistent. Because yung ibang libro kasi, ayun ang sign convention nila, no? Yung ibang libro, ang sign convention ay clockwise negative, counterclockwise positive. Okay. Pero sa discussions natin, just to be, you can use that, yung ganong sign convention. Pero sa discussions natin, just to be consistent na lang, clockwise positive, counterclockwise negative. Alright? So MA, moment at A, so moment ng F1 about point A, so counterclockwise yung kanyang rotation due to F1. So your negative 180 times its moment arm about A. Okay, so ano yung moment arm about A? So again, from F1, nag-drawing na kayong horizontal line. Sa point A, drawing a horizontal line. Draw a vertical line perpendicular to each lines. And then, malalaman nyo na ang perpendicular distance between the two lines ay ito. Perpendicular. That's 250. Convert na lang natin sa 250 mm. So, convert natin sa meters. Or you can use 250 if you want. That's okay. So that's 0.25 meters. This is in newtons, 180 newtons. Okay, and then proceed to F2. F2 is directed downwards, vertical, no? Alright, and it would tend to rotate yung box or yung rectangle natin. Rectangle box, I don't know. Yeah, it would tend to rotate the figure in a clockwise manner. So clockwise yung direction niya. Alright. So plus 180 newtons times moment arm. Moment arm niya is obvious naman ito. Perpendicular distance yan. So nililito pa kayo, drawing lang kayo ng vertical lines. Again, sa line of action ng 180 Newton force, and then sa my point A, so drawing natin ng vertical line. Yung line perpendicular to the two lines would be the moment arm, no? And that is actually equal to itong distance na yan. So ano yung distance na yan? That is 250 mm din yan, no? 250 mm kasi yung total niyan is 500 mm, 200 plus 300 is 500. Kung 250 mm yan, ibig sabihin 250 mm din ito. So that is 0.25 meters. Alright. Next, F3. Ito. Now, incline yung F3, convert natin sa components. F3x, F3y. So, let's start with F3x. F3x, ito yung point A, ito yung F3x. It would tend to rotate the figure in a clockwise direction, clockwise manner. So, plus F3x, which is 160. 160, opposite siya na, ito given yung ating angle, so opposite. So, that is sine of 30 degrees. Okay, that's F3x, no? This is 160 sine of 30 degrees times its moment arm about A. Moment arm niya about A. Again, you draw a horizontal line. Sige, i-set ko ulit na ito na example. So, pag-determine ng moment arm. Horizontal line sa may point A, horizontal line dun sa may line of action ng F3x. Yung perpendicular distance nito, dalawang lines, yan na yung moment arm ng F3x about point A. Okay. So what is that distance? Okay. So 250 plus 350, 600 yan. Okay, 600 minus 200. Okay. Ilan? 400. So yan yung distance na yan. Yan. So that is 400 mm yung moment arm ng F3x. I'm sorry. Convert pala natin sa meters. So 0.4 meters. Okay? Now moment naman ng F3y. So F3y, hindi yung point A, F3y would tend to rotate yung figure clockwise din. So plus, what is F3y? So F3y is 160 cosine 30. Okay? So F3y 160 cosine 30 times its moment arm. Moment arm about point A. So again, saktong-sakto F3y nandito sa line na mismo yan. A, ito rin yung vertical line niya. So obviously, ito yung moment arm ng F3y about point A. Itong distance na which is 500 millimeters or that is 0.5 meters. Okay? Next, tapos na tayo sa F3. Go to F4. So moment ng F4x about point A. Moment niya. So again, F4x tends to rotate the figure in a clockwise manner. So positive. So plus, ano yung F4x natin? That is special triangle 3, 4, 5. 3, 4, 5 yung hypotenuse natin. So since we are sa horizontal siya, yung horizontal side natin is 4 over 5 times yung magnitude natin na 150 newtons. So yun na yung F4x times moment arm ng F4x about point A. So obvious ang moment arm natin. Ito yung horizontal line of action ng ating F4x. Ito naman yung point A. So obviously ito yung ating moment arm which is 600 mm or 0.6 meters. Okay? So that's the moment of F4x. Next, moment ng F for Y. F for Y, this is point A, so it would tend to rotate yung figure in a clockwise manner. Clockwise. So, plus. Okay. Plus, 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 plus. F for Y, so vertical component. Goodness. 3/5 times 150 newtons. I forgot to include the unit. Times its moment arm about point A. So again, you draw a vertical line, you draw a perpendicular horizontal line to both lines. Yan yung distance, perpendicular distance between F4Y and point A. So obviously that is 300 mm, so it's 0.3 meter. Okay? So that's it. So one line lang yung ating solution. So MA is equal to 200.282 Newton meter. Since positive yan, clockwise yung direction ng moment at A. Okay? So I hope na klaro yung pag-solve natin ng moment, pag-identify ng moment arm, pag-solve ng moment. No? Alright. So, yeah, that's it.